thank you so much for coming. Hopefully you just had a good lunch. Hopefully you had some coffee as well. It's a Friday, last few sessions of the conference. How's everyone up there doing? I'm not convinced there's enough oxygen up there. I know Norwegians are good with extreme conditions, but that's ridiculous up there, honestly. So apologies if I don't look at you directly. It's probably because I'll crick my neck. So let's get cracking. My name's Shahid Iqbal. I'm a developer/architect. I have been for about 10 years. And more recently, I've been working as a freelance consultant, kind of doing hands-on projects with .NET and Azure. My contact details are all there. I don't think we'll get time for any questions today, so feel free to get in touch with me on those links there. So in terms of what we're going to cover today, large part of this talk is about Kubernetes. It's really an overview of Kubernetes. So if you know Kubernetes already, then this probably isn't the talk for you, so feel free to leave. I promise I won't be offended. So we're going to talk about creating clusters and deploying applications. Hopefully we'll have some demos as well. I want to talk about managed Kubernetes providers. This is one of the reasons I'm doing this talk, because managed Kubernetes providers have taken away some of the complexity of running Kubernetes for everyday people. We'll talk about PaaS versus container platforms, and then we'll finish about some of the things you may want to think about if you're looking to move to Kubernetes. So the key takeaways from this session: I want you to leave here with a really good understanding of the Kubernetes concepts and its high-level architecture. I want you to have the confidence to go away and create your own clusters and deploy your own applications, and really give you a launch pad from where you're going to move on and do some awesome things with Kubernetes. I want to caveat this talk by saying I'm going to talk about containers, but I'm not going to talk about how we create containers. Hopefully, those of you who are new to Docker went to the session this morning on how to create containers. The other caveat I should make is, although the title mentions .NET, there won't be any .NET code, so sorry about that. There will be a .NET application, though. So what is Kubernetes? Kubernetes is an open-source container orchestration platform originally created by Google. It was based on a couple of internal projects, one called Borg and another one called Omega. It's written in Go, and it's 100% open source. And actually, Google donated the project to the Cloud Native Computing Foundation, who are a subset of the Linux Foundation. Because they donated the project, this is one of the reasons I believe that Kubernetes has seen such an uptake, because it's no longer owned by Megacorp. Before we go too much further, worth covering this topic quickly. You often see Kubernetes shortened to K8s or Kates, and you may be wondering where that comes from. Essentially, it's just a K, and then if I can get this fancy pointer to work, it's 8 letters between the K and the S. That's all that is. Before Twitter increased the character count, I was trying to get C8s into common usage, but that failed miserably, so we'll have to move on from that. So why do you need something like Kubernetes? Well, I presume most people here are developers. Yeah, most people. And I presume a lot of you are .NET developers as well. So up till recently, you were used to deploying applications to VMs or physical machines. And you would deploy your application, and that was fine. But when you needed to deploy another application, you needed another VM or another physical machine, because you needed to isolate those applications. And that's fine. We can do that again and again. One of the downsides, or a couple of the downsides, is you're not necessarily using all the hardware on each of those VMs. The other problem is you're paying for Windows licenses if you're deploying full .NET Framework applications. Now, of course, we know in recent times the world's moved on. We're into this awesome world of containers. So now what we can do is we can deploy multiple containers on our machines. That's great, because now we're packing our machines out. We've got a lot more containers on there. We're using fewer machines, so we're paying Microsoft less money as well, which is great. They take it in other ways, though, so don't worry. But what happens if that machine dies? You need to know that that machine died, but hopefully everyone has some good monitoring in place. You need to figure out what was running on those containers, on that node, which containers were running, and you need to find somewhere else to run them. Now, of course, all of that's manual. That means somebody is being paged at 2 in the morning and has to go and do that. And this is where container orchestration platforms come in. They allow you to take a bunch of machines and essentially install something like Kubernetes across them. So what you're doing is you're taking a bunch of machines and you're meshing them together, if you like, into a bunch of compute, memory, and networking. Then you deploy your applications on top of that. Particularly as developers, you don't care about the underlying nodes anymore. If one of the nodes dies, it's the Kubernetes job to figure out that there were some containers running on that node, and they're no longer there, and find somewhere else to run them. So that is container orchestration at a high level in a nutshell. Let's quickly talk about the kinds of companies using Kubernetes. It's no surprise, some of the biggest companies in the world are using Kubernetes at the moment. Probably the only one of interest to call out, really, is GitHub, or I guess Microsoft GitHub, because Kubernetes is deployed on GitHub, and GitHub uses Kubernetes. So it gets a little bit circular. I'm not sure when one thing goes wrong, what would happen. So where can I run Kubernetes? You can run Kubernetes on-premise. You may have a data center. You may have bare metal servers. You can download and install Kubernetes on those bare metal servers. More commonly, though, you're going to have some kind of private cloud or infrastructure as a service. So VMware, OpenStack are common ones. You can deploy containers on there as well. Sorry, Kubernetes on there as well. You can even deploy Kubernetes on Raspberry Pis. Some of you may have seen Scott Hanselman's demo where he has a Raspberry Pi cluster. It's pretty cool. But you probably wouldn't run any large-scale production apps on a Raspberry Pi cluster. Of course, you can provision infrastructure in the cloud, and you can install Kubernetes on there. And that's a very common pattern, actually. And then the third option is reasonably fast-moving, is these managed Kubernetes providers. Now, I haven't listed every provider. There's not enough space on the slide. So I'll call out the 3 main cloud providers. I'll talk a lot more about this in a later slide. So just to say, the managed providers give you a lot more simplicity in running Kubernetes versus doing it yourself. So what about cost? I mentioned at the start, Kubernetes is free and open source, and that's awesome. But free and open source doesn't work so well with some companies. Particularly large-scale enterprises, they need enterprise support. They basically need somebody to sue if there's a problem. So this is where there's commercial offerings. So OpenShift from Red Hat is probably the most well-known. In fact, it's not what's called upstream Kubernetes. It's actually Kubernetes where they've bolted on additional bits to it to give you enterprise-level features. There are a number of other providers. Canonical are one of those. I won't mention everyone. We don't have time. A third option, or another option, is these consulting companies. So Heptio is probably the most well-known. They're a US-based consulting company. They offer this Heptio subscription service. Essentially, they will support Kubernetes in any of the public clouds. And then there are a number of other companies. JetStack is a UK-based company who do a lot of training and consulting on Kubernetes. I don't know of any Norwegian companies, but if somebody can educate me, that'd be awesome. So let's have a look at some of the features of Kubernetes. We talked about container orchestration at a very high level. That's one of many features. We have the ability to have horizontal scaling. We can do rolling deployments and rollbacks. We have self-healing, service discovery and load balancing. We can even run batch jobs on Kubernetes. A lot of people think about Kubernetes and containers as being long-running jobs, like a web server. But you can actually do data processing and similar jobs. Containers will spin up, do a defined task, and then they'll shut down again. In order to provide these features, Kubernetes has a number of components. Now, I'm not going to talk through every one of these components. I think the key takeaway from this slide is Kubernetes has a lot of capability, but you don't need to know all of it to get started. What I'll do later, hopefully, is demonstrate that you can get started without knowing many of these. And then as your needs evolve, chances are Kubernetes has that capability in the platform already. And if it doesn't, there's almost certainly an open source project out there which you can use. So let's look at the high-level architecture. And it's pretty standard distributed system. We have the master nodes. You usually have more than one because you need highly available master nodes. And that exposes an API. Then we have these worker nodes. And the worker nodes are where your containers run. So unlike some container orchestration platforms, by default, your containers don't run on the master nodes. You'll also note, let's see if I can get this pointer to work. The master node is Linux only, but the the worker nodes are Linux and Windows, although the Windows support is currently in beta. And that may give you a hint to where I think the .NET Framework possibilities are. Let's dive a little bit deeper into the master node. The master node exposes an API server, and this is how you would talk to Kubernetes. You can use the UI. A lot of people prefer to use the command line tool called kubectl. Well, I call it kubectl. Other people call it kubectl, kubecuddle, kubecuddle. Basically, this is tabs versus spaces in Kubernetes world. I promise you, you will find this crop up again and again. Then we have the scheduler. And the scheduler's job is to figure out where to run your containers. Kubernetes has some really powerful concepts around giving hints to the scheduler around things that your containers may need. So a good example here is you may have some machine learning workloads on your cluster, and you may have some nodes within your cluster that have GPUs. You can hint to Kubernetes that you want a GPU for your particular workload, and Kubernetes will schedule those particular containers on the nodes that have that GPU. Then we have the controller manager. This is basically one of the key control loops within Kubernetes. Its job is really just to monitor the cluster, make sure the nodes are up. Pretty standard, really. And we have the cloud controller manager. And as the name suggests, this was actually spun out from the controller manager in recognition that when you run Kubernetes on a public cloud, you need to provision public cloud resources. You need to talk to the public cloud to provision resources. Common examples here are you need a public IP address, you probably need a load balancer. And then all of the state and configuration within the cluster is stored in etcd, which is a clustered key value store. So if you're running Kubernetes from scratch yourself, it's really important that you have a backup strategy and recovery strategy for etcd in particular. Probably worth mentioning, if your master nodes go down in a cluster, your workloads won't be affected. They'll continue running. You just won't be able to change the state of your cluster. Let's have a look at a worker node. So worker nodes have a kubelet, and this is the main agent that runs on a node, and essentially is what makes it part of a Kubernetes cluster. You have the kube proxy, and its job is to deal with the networking. And then we come to this container runtime. So I mentioned at the start about Docker, and Docker is probably the most well-known container format there is. There are actually other formats out there. Kubernetes doesn't take a hard dependency on Docker. It uses a container runtime interface to abstract the specific container format, and you can swap out the particular container flavor you prefer. We have a couple of supporting services I won't talk too much about, and then we have these pods. And the pods are actually where your containers live. So Kubernetes doesn't deploy containers, it deploys pods. And a pod is the unit of deployment and the unit of scale. Typically, your pod will have one container, but in some situations, you may have more than one. As I said, the important thing is, if it makes sense to scale and deploy together, then they make sense to be in the same pod. Example where you may have more than one container in a pod is you may have an application that's writing log files somewhere, and you have another container which is grabbing those log files and pushing them somewhere else. In that situation, the supporting container is often called a sidecar container. So if you want to work with Kubernetes, do you need to have access to a cluster, whether it's on-prem or whether it's in the cloud? The answer is no. You can run a cluster on your local dev machine. You do need to have virtualization capabilities on your machine, but you can run either a project called Minikube, which is a subset of the Linux project, of the Kubernetes project, or you can use Docker for Windows and Docker for Mac. Recently added support for Kubernetes as well. It's probably enough talking. Let's flick over to a demo, and we'll deploy some containers. Just cool. Now, if you want to get started with Minikube, it's on GitHub. But if you're particularly on Windows, I would use Chocolatey. It's far easier to install it with Chocolatey, and it's far easier to maintain as well. So let's flick over to console. Can everyone see that okay at the back? Cool, thank you. So I mentioned the debate over how to pronounce kubectl and kubectl or whatever. I've aliased it to K, so we don't have to spend time arguing about it. So what I can do is I'm connected to its local cluster, so I can do something like just give me some cluster info. It gives me some information. It doesn't really matter too much about what that is. What I can do is I can do k get nodes. That gives me status of the nodes. You can see there's one node, and it's version 110. So let's deploy an application. So I've got a ASP.NET Core application in a Docker container on Docker Hub. So what I can do is I can say kubectl run. I need to give it a name, so I will call it, let's call it hello world because I have no imagination. I'll specify the image I want, which is that. Let's make sure I give it the tag, and I want to expose port 80 on that container. So that's now gone and created a deployment, so I can have a look at the pods. So I do k get pods. You can see I've got one pod running. So that started up very quickly. It's partly because I've already done this demo once, and the image is cached. I wasn't going to rely on the Wi-Fi to pull a Docker image, I'm sure you can understand. Incidentally, when I did k get pods, you can shorten this to k get po, and it gives you the same answer. Now, I'm not sure what you'll do with all the time you save. Probably write a book or spent time with the family, I'm not sure. But I just wanted to mention that's there. So now I've deployed an application. I want to have a look at it. So what I can do is I can expose this. And I'm going to expose the deployment called Hello World. And I'm going to, I'm going to expose it on port 80. And I'm going to use this type called load balancer. And I'll explain what that is in a little bit. Let's get this right. There. Now, if I do get service, you can see I've created this new service up here. It has this cluster IP address. And again, I'll explain what that is in a minute. And then this external IP address is showing as pending. Now, because I'm running on this desktop machine, there's no infrastructure to provision a load balancer for me. So I need to do a slight trick. So let's just move this up. So I just need to get Minikube to give me the URL. Let's type that out for that particular service. So Minikube will think about it for a second, and it gives me a URL. Let's just copy that. Let's pop open a browser. And we can see my application. Now, you can see I spent hours and hours on the design. I've literally maxed out my design capabilities. You can also see down here, what I did is I listed environment.machine name. And actually, that corresponds to the pod name. So if you see up here, that's the pod name. So that's great. I've got one instance of my my application running. Well, if I want more, so I can scale this up. So I can do kubectl scale. So I want to scale the deployments. And I want replicas to be 4. If I now do kget pods, and if I'm quick enough, we'll see it being created. So you can see 3 already running, and then 1 is still being created. If I just refresh that, we'll see they're all up and running. So that was the original one. And now we've got these 3 new ones. So it's easy as that to scale. So now if I come back to the UI and if I refresh, what we may see is load balancing. So we may see that particular machine name change. But because the application is so lightweight, it doesn't often do that. So what I can do is I can use this as an opportunity to demonstrate a different feature. One of the key concepts within Kubernetes is desired state. You tell Kubernetes you want your application to be in a particular state, and its job is to monitor that and ensure that happens. If something happens to change that, Kubernetes will take rectifying action. So in this case, if I delete the pod with that name, and now if I go to get pods, if I'm quick enough, what we can see is actually there's 4 pods running already, and that last one is terminating, the one that was serving the traffic before. If I come back to the UI and refresh, we'll see now one of the other pods has taken the traffic. So that's a really quick intro into deploying a container, having a look at some scaling, and resiliency. So let's pop back to the slides, and we'll talk about a different way of deploying applications rather than typing everything at the command line. So as I probably showed there with my typing, you don't want to be typing those kind of commands in a command line. It's not a great way to work. So Kubernetes has a concept of configuration files. These are basically YAML or JSON files. Although, to be fair, JSON is so last year, so everyone's using YAML files. These files describe your application structure and the resources they need. They define the desired state of your application. So the way to think about this is the containers are your application. These configuration files, they are your infrastructure as code or your configuration as code. So if you have these, they need to be in source control. So let's take a look at one of these files. Hopefully that's quite visible. That's not too bad. So I'm not going to talk through the whole file. I'll just call out a couple of things. So up here, we can see, my cursor behaves itself. It's a type deployment. We have these labels, and I'll come on to where they're relevant in a minute. So app, their key value pairs, basically, app HW. We've got the replicas defined here. And then down here, we've got the spec for the container. So we can see the image I'm referencing, and you can see the container pool I'm referencing. Now, if I want to deploy this, I would use kubectl create-f, and I'll give it a YAML file. So you'll note that I'm not defining the resource. The YAML file is self-describing. Now, you're probably looking at the YAML file and saying, well, that's a lot more complicated than running kubectl run that I did. And that's fair enough. But obviously, you don't want to do that in real life. So what often people do is they'll find a sample of a YAML file and they'll copy it. And that usually works fine. But on occasions, the APIs may have changed, and it's not a great way to work. So a handy tip is you can append --dry run to the end of most kubectl commands. And essentially, kubectl will validate that command. It won't run it. It will just validate it. And you can then output the result of that into YAML and pipe it to a file. So in the case of the run command I did before, all I've done is appended that at the end. And that's how I got the YAML file I just showed you. It's as simple as that. I wrote a quick blog about it if you need more details at that address there. So right, we've deployed our application. How do we access it? So of course, we're running more than one instance of our application. So how does a client access it? The answer is we're using something called a service. So service is a well-defined endpoint which will load balance the traffic across the underlying pods. And the clients, whether they're outside of the cluster or inside of the cluster, will use the service to access your actual application. In this case, if a node dies, Kubernetes will detect that. It will move the application to one of the other pods. But your consuming application doesn't care because it was one of the other pods was serving the traffic. So if we have a look at how we deploy a service, so this is when I typed the kubectl expose command, I created a service. Service is similar structure, but a lot simpler. As you can see, type of service up there. Here we're telling which port we're going to expect traffic on, which port we're going to route the traffic to. And then this selector, this is the important bit. So the way services work is they're loosely coupled from the underlying pods. They use this concept of a selector to find the pods which they should load balance across. So it's like a predicate. What they say is, give me all the pods that have this particular label, and I will load balance traffic across them. In that situation, Kubernetes can create more or fewer containers. It can move them around, and the service doesn't care because it will just find them. And that's how we get loose coupling. So I talked about a load balancer service. There are a number of other service types, so it's worth covering them. So essentially, a load balancer type service says, I want to expose this application publicly. Now, it depends on where you're running. As you saw with my desktop machine, there was nothing to expose. If you run on the cloud, this is where you'll provision a load balancer and a public IP address. So this is where that cloud controller manager comes in. You have the cluster IP address. Essentially, this says, this application is internal to my cluster. It's not exposed publicly. We have something called a node port, and this is quite an interesting one. Essentially, it opens a port on every node in your cluster, and if traffic arrives at that port, it will get routed to your application, no matter where your application is running within the cluster. So it doesn't have to be running on that specific machine. It will find your particular application. So that's pretty cool. And then external name allows you to create essentially a Kubernetes service that has no pods, and it references an external service. So this is a nice way of potentially moving some applications into Kubernetes without moving all of their dependencies with it. So that was a kind of quick tour about deploying applications and YAML files. Let's have a quick chat about some of the features. The first one I'll talk about is health checking, or liveness probes, as they're called in Kubernetes. Kubernetes allows you to define an endpoint in your application, which it will periodically poll, and depending on the response, it will decide whether your application is healthy or not. So you can do a HTTP endpoint, you can do a TCP endpoint, or you can even do basically a shell script, an exec, just run this command in my container. In the case of HTTP, if the response code you get back is between 2 and 400, Kubernetes deems that to be healthy. Anything else, it will say this application is unhealthy. When that happens, it will restart that container. When it does, hopefully your container will come back up and it will be healthy again. If it doesn't, Kubernetes will do that again, and eventually it will start backing off to avoid, obviously, looping. In a very similar vein, we have something called readiness checks. So readiness checks essentially say, my application is up, it's healthy, but it's not ready to receive traffic just yet. So an example here might be you're pulling some config data from an external server somewhere. Maybe you're priming some caches. Depending on the status code, Kubernetes won't send any traffic to that pod. As soon as the the end readiness check says we're ready, then traffic will start arriving at that pod. So it's quite a nice way to manage those two different states. And these two checks are used quite often in deployments. So let's get on to the exciting bit. So Kubernetes allows you to do zero downtime rolling updates. And that's like the gold standard that everyone wants to achieve. Now I'll say to you, do you really need zero downtime rolling updates? Or is it just a vanity thing? Because they're not easy. and I'll explain why in a second. You can also do blue-green deployments, and you can also roll back, and we'll have a look at some of these in a minute. So the key thing to note here is, just because Kubernetes can do zero downtime rolling updates, it doesn't mean your applications can support it. You need to be able to deal with breaking changes in your schema or data as you roll across the versions. As we'll hopefully demonstrate, you'll be running more than one version of your application at the same time, so you need to be able to deal with that. Hence why I said, do you really need it? In order to perform these updates, Kubernetes uses two key parameters, max unavailable and max surge. And it's the balance of these two parameters that decides how quickly a new deployment rolls out versus how much capacity on an existing service is lost during the rollout. So what I mean by that is, you may have an application with 5 instances running, and it's under heavy load. You can afford to maybe lose 1 instance, but any more than that, you will start affecting your traffic. In that situation, what you would specify is a max unavailable of 1. And then, contrary to that, you can also specify max surge. This says, how many new pods do I create during a deployment? And the reason why you can't necessarily max this to 100%, because you may not have enough capacity in your cluster to run twice as many services as you are at the moment. Now, of course, I think this is quite hard to visualize, so let's try and do it in a more visual form. So in this case, I've got a service deployed. I've got 3 instances running, and I've said max unavailable of 0. But I'm allowing it to surge up by 1. Kubernetes will do when we start the deployment, it will create a new instance of our application, the V2. It will wait for that to be ready and healthy, assuming you've defined it. And then it will switch the traffic over. So you notice we're now surged up to 4. It will take one of the existing services out of the load balancing, and it will give it 30 seconds by default to finish what it's doing before it sends it a term signal. We're now back to 3 services. No surprise, really. Process repeats itself. We have surged up to 4 again. We're back down to 3 now. And you'll notice at no point are we losing any traffic. We still got 3 pods as a minimum serving the traffic. Eventually, as we roll over, we're now all the way over to that last pod will die, there we go. All the way over to our V2 application. At no point did we have any downtime, but you do notice we had V1 and V2 traffic at the same time. That's really important to note. Another common pattern is blue-green deployments. Come on, clicker. Blue-green deployments are quite a common pattern. So here what we're doing is we're defining max unavailable of 0, max surge of 100%. So those numbers can be number of pods or percentage. So I'm sure most of you have probably guessed what's going to happen here. We'll create 100% of the new pods, wait for them to be ready and healthy, and the traffic is switched over to the new pods. The old pods are allowed to finish what they're doing, and then they will die. So that's a blue-green deployment. Let those die. OK, so that was a quick kind of tour of some of the features in Kubernetes. I could probably spend days talking about some of the other features. We really don't have time, unfortunately. If you want to be bored, I'm here for the rest of the conference, so come and find me, and I'll bore you to death. Let's talk about managed Kubernetes providers. So what I'm talking about here is, of the 3 main cloud providers, we're talking about AKS from Azure, GKE from Google, and then the recently released EKS from Amazon. These providers take care of the hard work of running a Kubernetes cluster. They take control of that management plane. They take the responsibility for making sure it's highly available, it's backed up. So this removes one of the biggest overheads of running a Kubernetes cluster, and it means Kubernetes is accessible to a lot more companies. Those companies who may not have a huge DevOps team, a huge ops team who can run a cluster. In the case of Azure and Google, you don't pay anything for those master nodes. In fact, running Kubernetes on those 2 cloud providers is exactly the same as running standard infrastructure in the cloud. Amazon, strangely, decided to charge for their cluster, and also creating their cluster is a little bit more tricky as well. I'd be shocked if they didn't change that decision at some point. Let's talk more specifically about Azure, because that's the one I work with mostly. So Azure Kubernetes Service, AKS. As I said, the management plane is kind of taken control from you. You can't even see it, actually. There's a downside to this. You lose some flexibility. You can't control some of the startup parameters. But that's a trade-off you always have when you have a managed service. You can run multiple versions of Kubernetes on AKS. And if you're feeling really brave, you can upgrade a cluster in situ. Now, remember what I said. Your cluster doesn't necessarily go down during an update. As long as the master nodes come back at some point, you should be OK. Recently, they've announced the ability to integrate Kubernetes into existing VNets. So a lot of companies will have strict networking structures. VNets, for those of you who don't know, is equivalent of VPCs in Amazon. Very recently, they announced the ability to use roles-based access control using Azure AD. You can also scale the nodes using the CLI or the portal, and auto-scaling is on the horizon as well. And finally, the nodes are auto-patched for you. So if there's an issue with the operating system, the nodes will be patched for you, but they won't be automatically restarted. But there's a community project out there which will actually detect when a node has been patched and will restart it for you in a Kubernetes-safe way. So it means none of your applications will actually go down. The really exciting thing is, as of Wednesday, AKS went into GA, which means you can now use it in production, and it's available in 10 regions across the world. So how do I create an AKS cluster? It's actually very straightforward. You need to create a resource group, which is pretty standard for anything you do in Azure. Then to create the cluster itself, it's literally one line. AZ AKS create, you give it the name of the cluster, and you give it the resource group you just created. Now you can specify additional parameters if you want. You can specify the Kubernetes version, number of nodes you want, the size of the VMs, a whole heap of other options, but you don't need to specify those. That will give you a cluster. Now it takes about 10 to 15 minutes to create a cluster, so I've got one already running. So what we'll do now is we'll do some of the same steps we did on the local cluster. We'll do it on the cloud cluster, and then we show off some of the features I've talked about with some demos. This is where I need the Wi-Fi to work, so fingers crossed. I'll just close that to avoid confusion. So a really nice thing with kubectl is it allows you to work with multiple Kubernetes clusters just by changing the context. So my previous demo was working with a local cluster. I can now switch to a remote cluster just by changing the context. So I do config, I tell it to use a context, and I'll give it the context name, which is HFC K8. If I just clear that now, if I do k cluster info, oops, we'll see some other information. Doesn't really matter what it is. Some hints in there, it's running in West Europe, whatever. If I now do k get nodes, we can see I've got 3 nodes in this cluster. And also note, there's no master nodes there. All of these say they're agent nodes. That's to reinforce that point. OK, so let's deploy the same application onto AKS this time. Now, I said you shouldn't do it imperatively by typing the command line, so I will use the YAML files. So I'll go and deploy these, and then we'll have a look at the YAML files, because I've added a couple of extra things to them. So if I do k create -f, and I'll give it the deployment file, we'll do that. Do the service. I'll just clear that. So if we do k get pods now, we'll see that pod's up and running already. If I do k get svc, see the service. This time, so you see it's the same service as before. This time, when it says pending IP address, Kubernetes is talking to Azure, and it's asking to provision a public load balancer and an IP address. Now, that takes anywhere between 1 minute and 3 minutes, depending on whether I'm demoing or not, and how many people are watching. So rather than waiting anxiously for that, let's have a look at the YAML files. I should call out a couple of things. Can everyone see that OK at the back? Good, thumbs up, that's good. Most of this file is exactly the same as I showed you. I've got the rolling update strategy in here. The interesting bit is this liveness probe. So it's what I talked about with the health checking. So I've said to Kubernetes, let's move that out of the way, to probe my application at home/health, use port 80, initially wait 3 seconds, and then poll that every 3 seconds. So that's doing the health checking. Let's have a quick look at the service. It's actually exactly the same as I showed you in the snippet, so there's nothing interesting there. Let's come back to the terminal. We'll see if our service has been created. Oh, it has. Great. Before I go into there, it's probably worth showing you the Kubernetes dashboard. There's a couple of ways of accessing this. The easiest way is using the command line, the Azure command line. So AKS browse. I'll give it the name of the cluster. I'll give it the resource group. Oops. What that's going to do is going to open a secure tunnel from my laptop to the Azure cluster, and it will eventually pop up in a browser window and load, fingers crossed, Kubernetes dashboard. Sorry, the Kubernetes, UI and dashboard. That's quite big. Let's shrink that down. So I'm not going to talk through all of this. We just don't have enough time. So you see our deployment here. I can do some actions in here. I can scale it if I want. I can delete it. I can edit the YAML. I can create new deployments if I want. I can see the number of pods I'm running. Nice thing here is I can actually click on here, and I can see the log files from that container. And as you'll see, it's basically just an ASP.NET Core application. It's what you would see in Visual Studio if you're running this. If I come down to the services, see, that's the IP address that Azure assigned it. And no surprise, you see the same application now running on Azure. So what we can do now is let's have a look at that health endpoint I talked about. So I think it was home/health. If I do that, it's essentially returning a 200 OK. And that's fine. Now, I don't know about you, but I never have bugs in my code, only undocumented features. So for this demo, I've had to do something rather horrendous. Horrendous for two reasons. One is I've got an endpoint which will kill my application. That's pretty bad. I'm also mutating an application on a GET request. Special place in hell for people who do that. OK, so that's now saying it's sick. If I come back to the terminal, I'm just going to kill this tunnel. I'll just clear the screen for a second. If I now do get pods, what we should see is the restart count's gone up. So you see that's now showing as 1. So that's basically auto-healing in action. The next demo I want to do is a rolling update. This one relies on a really stable connection while I'm doing this from this machine. So what I've got is a video instead, which I think was slightly easier to follow as well. So I'm just going to switch to the video, and we'll play that video. So just to set this up, I've got the same application deployed. If you look on the right-hand side as you see it, you can see there's a terminal pane there, and I've just curled the endpoint, and I've grabbed the H1 tag, and it's showing as V1. I'm going to run on the left-hand pane as you see it as well, great. I'm rubbish with left and right, sorry. I'm going to edit the YAML file, and we're going to change the container image. While that's running, you'll notice I'm using Windows command. Essentially, I'm doing grep, curl, nano. We live in a strange world now as .NET developers. So I'm about to run this deployment. Before I do that, I'll run this batch file, which is looping over that same curl command, and it'll start displaying the V1. Now I apply this deployment. This will trigger a rolling deployment. We can have a look at the status of that by pressing status. We can see the rollout's proceeding. If you look on the right-hand side pane, you can see V2s are now starting to appear. Hopefully this reinforces we're seeing V1 and V2 traffic at the same time. Deployment's now finished, and we're only seeing V2 traffic. So what you can do now, when I get around to canceling it, I should pretend I'm typing here, shouldn't I, just to make it look authentic. You can have a look at the status of any particular deployment. You can look at the history of it. So history shows us we now have 2 versions. We had one original revision, and we've changed it. What you can do now is you can undo to any revision you want. If you just deployed something and it's bad, you can just do a simple undo. So what we'll do now is we'll go ahead and undo that deployment. So before I run that, I'll start the same loop again. You can see it's V2. The hotel Wi-Fi seemed to have paused at this point, so we'll give it a second to catch up. And there it is. So we see we're getting V2. We start the deployment or the rollback. Again, we can look at the status, and it shows us it's currently rolling out. And we're starting to see some V1 traffic appearing now. As that proceeds, update will finish, and then eventually we're only seeing V1 traffic now. So that's basically a rollback. So those last few demos hopefully showed you health checking and rollback. Let's flick back to the slides, and we'll carry on. How am I doing for time? Got about 20 minutes, which is good. that was the last demo. So I've talked a lot about Kubernetes, haven't talked much about .NET and, I guess, by association, Microsoft. So Microsoft contribute to the Kubernetes project. I think in the GA release, there were about 17 individual contributions to the Kubernetes project from Microsoft members. Last year, about a year ago, they acquired a company called Deis, who are very big in the Kubernetes space. So Microsoft really bolstered the in-house Kubernetes expertise by acquiring that company. Brendan Burns, who's one of the original founders of the Kubernetes project, works at Microsoft as a distinguished engineer. And then the area I think is quite exciting for .NET developers is Microsoft's traditionally been very good at providing us with tooling. So that Deis team on the Microsoft team has released a number of products already. One's called Helm, which is another way of deploying applications to Kubernetes. Something called Draft, which allows you to have a debug and development time experience against Kubernetes. Brigade, which is an event-driven framework for Kubernetes. And then more recently, something called Azure Dev Spaces, which is quite an exciting prospect, which I think is a game changer for companies who are developing large-scale microservices within their dev teams. Because one of the challenges you have with microservices is you potentially have to run all of your dependent services when you're doing development. So you end up needing dev machines with 20 gigs of RAM and something crazy like that. Or you end up running tons of clusters in the cloud, and it means you can't necessarily work offline as well. So Dev Spaces makes that a lot simpler. I don't have time to really go into it, but you'll hear more about that. It was announced at, it was formally announced at Build, I think, and certainly you'll hear more. So where am I excited about Kubernetes as a .NET developer? Well, I see Kubernetes potentially being a single platform for all of our .NET applications. So we can create hybrid clusters containing Linux and Windows nodes. You can't do this in AKS at the moment, but you can create these hybrid clusters if you want to. So we can deploy, full .NET Framework legacy applications and .NET Core applications to the same platform, which means you can use the same CI/CD approach. The really nice thing with this is, when you are breaking a monolith up to microservices, one of the challenges you have is how do I join those two bits together? How do I sort the plumbing out? If they're all running in Kubernetes, that's taken care of for you. So the kind of vision I see is we have .NET Core code, we have full .NET Framework code, goes through the same CI pipeline. You build either a Linux container or a Windows container, and you deploy that to Kubernetes, and you manage it in exactly the same way. You don't care about the underlying framework. So that was, let's just switch now a little bit and talk about container platforms versus PaaS platforms. I'm sure most of you got this question. I'm already running on something like app service. Why would I want to switch to something like Kubernetes? Well, I think PaaS platforms are fantastic. And if you're already using them and you're happy with them, you've got no reason to change. One of the areas I see being problematic is as the number of services grow, it can get a little bit complicated to manage on a PaaS platform. Now, of course, PaaS platforms are adapting as well, so there's a lot of blurring of the lines now. One of the other potential issues with PaaS services, or people say, is they lock me in. There's vendor lock-in. Now, I personally don't buy that argument at all, because almost every PaaS platform allows you to deploy using Git or zip file of some kind. So I call BS on that argument. Container platforms, on the other hand, are definitely harder compared to PaaS platforms to get started with. And actually, they're harder to maintain ongoing as well. So although you've got these managed providers, you still need some expertise in your company who understands Kubernetes. But Kubernetes kind of platforms, so container platforms, have a lot more scope to mature with your application and your platform. So you saw all those features at the start I mentioned, and we didn't use, I think we used about 3 of them in the demo so far, and we deployed applications fine. So as your needs develop and complexity increases, chances are you've got that capability there. So the way I like to think about it is you've got the flexibility of infrastructure as a service with the features you normally get with the PaaS platform. So you get auto-scaling, you get self-healing, and you get this kind of rollback and deployment support. So it's all great. You want to think about moving to Kubernetes. So my first comment on this, don't get sucked in by the hype. So I know that's strange. I've spent the best part of an hour, 45 minutes, talking to you about how cool Kubernetes is, and it definitely is. But I really want to stress, just because it's cool doesn't mean you should be using it. Just because your management think it's cool and they want to put in the marketing information doesn't mean you should use it. You need to assess it for your own purposes. If you've got organizational problems, throwing Kubernetes in the mix will not solve them. If you've got technical debt and you've got other problems, Kubernetes is not going to solve that for you. Instead, focus on the basics. Ensure you're developing 12-factor style applications. Ensure you're logging properly. Ensure you're using health checks and endpoints, readiness endpoints. Those are cheap. You can do those now. Have a clear plan for your architecture and your microservices. Again, Kubernetes is not going to give you that answer. Look to migrate all the code that you can to .NET Core. And CI/CD pipelines are absolutely critical on this, particularly if you have Windows containers. Because every month, you'll have Patch Tuesday, and containers are immutable, so you need to redeploy the containers. So you don't want to be doing that manually. Look at containerizing your legacy .NET Framework applications, those which you are no longer working on, or you have no idea how to modify, or literally can't modify to .NET Core. Containerize those to Windows containers. One of the reasons why I'm encouraging people to move to .NET Core is because the Kubernetes ecosystem is largely Linux-based. Most of the people in Kubernetes project are Linux-based. Windows containers will, unfortunately, for a long time, still lag behind Linux containers. And therefore, if you want to use the newest features, you really want to be looking to move to .NET Core. But we have the option for those applications which we can't move, so we can still take all the advantage of Kubernetes. Finally, you want to be looking at a process called GitOps. Sorry, it's another buzzword. But essentially, you want to make sure that your your cluster is disposable. So you're not creating an artisanal, handcrafted snowflake cluster. You're in a position where you can delete your cluster and reprovision everything with one click. So, talked a lot about Kubernetes. What about the alternatives? Well, we have Docker Swarms, probably the most well-known. A lot of people say Docker Swarm is very easy to get started with. And then other people say you run out of road very quickly with Docker Swarm as well. We have DCOS from Mesosphere, very popular in large enterprises. Seems to be focused a lot more around big data processing. And then we have Service Fabric from Microsoft. And again, that's essentially a container orchestration platform, because you can just give it a container and it will run it with a lot of the same capabilities we've talked about. Reality is, Kubernetes has eaten all of these. Docker now support Kubernetes. Mesosphere now support Kubernetes as a scheduler within their products. And of course, Microsoft are heavily invested in Kubernetes as well. So to summarize, Kubernetes is a mature, feature-rich container orchestration platform. Many big companies are betting and have bet their future on it. Windows support is gaining traction. And Microsoft is clearly heavily invested in it as well. And I think the tooling and the support from Microsoft will make the adoption for .NET developers much easier. It's not too bad now. It'll be even easier. So if you want to learn more, I highly recommend having a go on Katacoda. This is a fantastic free online learning platform. So if you have a laptop that can't run virtualization, or you have a corporate laptop that's locked down and you can't run anything on it, as long as you've got an internet connection and you've got a browser, you can go and have a play with Kubernetes. You can have a play with many other very cool cloud-native technologies, all through your browser. It's an awesome platform. The book, Kubernetes Up and Running, is a fantastic book. Often with these kinds of platforms which are fast-moving, people will think the book's going to be out of date straight away. But actually, this book does such a good job of covering the basics, the fundamentals so well, that I don't think it will go out of date. It'll be relevant. And finally, the Kubernetes documentation is fantastic. Every time I go in there, I find a new nugget of information. With that, I think that's my time. It's not my time, but that's the end of my slides. That bit.ly link will give you the slides, although the current version on there is slightly older version. What I'll post is a longer form version of this talk. My contact details are there. Otherwise, if you've got any questions, probably easier to come down and have a chat with me. I don't think this arrangement works so well with questions. With that, say thank you very much for coming. Get to vote, please, as well, on the way out. I appreciate that.